A relation R subset of A cross A is symmetric if this statement is true. As an example, consider the relation R, subset of A cross A, where A is the set containing the numbers 1, 2, 3, and 4. And suppose that our relation R is defined by this graph. Now, as we know, this first edge from 1 to 2 tells us that 1 is related to 2. And this edge from 2 to 1 tells us that 2 is related to 1. And this edge from 3 to 4 tells us that 3 is related to 4. And this edge from 4 to 3 tells us that 4 is related to 3. And lastly, this self-loop from 4 to itself tells us that 4 is related to 4. Now, as I said in the previous video, this statement up here in blue, in the blue box, defines many if-then statements. It defines an if-then statement for any two numbers in A. So let's see. Let's pick two numbers in A, 1 and 2. Okay, so 1 and 2 would give us 1R2 implies 2R1. And 2 and 1, right, would give us 2R1 implies 1R2. Similarly, we have 3R4 implies 4R3, and 4R3 implies 3R4. And if you pick two numbers, 4 and 4, then you get 4R4 implies 4R4. And now I'm not going to write out every single possible one of these that there could be because there's not enough room on this page. But let me just write out one of them. Let's say we pick 1 and 4. Okay. 1R4 implies 4R1. All right, now let's pretend that I wrote out all the other ones so you have two numbers in A that are not related. Okay, so the rest of my table here is going to have all these other ones where the two things aren't related. So 1R3 implies 3R1. 2R3 implies 3R2, and so on and so on. All right, so I'll make a table like I did in the previous video. We have P implies Q, and true or false. And remember our truth table definition of P implies Q. Okay, so now let's look at this very first row here. Is 1 related to 2? Yeah, we saw that over here, right? Right there. So that's true. Is 2 related to 1? Yes, that's true. Okay. Now let's see, reversing the order of these things. If 2 is related to 1, then 1 is related to 2. Let's see, 2 related to 1. Yeah, we saw that's true. 1 related to 2. Yeah, that's true. Okay. 3 related to 4. See that right there. That's true. 4 related to 3. We see that right there. That's true. And again, 4 related to 3. We know that's true. And 3 related to 4. That's true. Now 4 related to 4. 4 related to 4. Yeah, that's true. And that's true. And now 1 related to 4. This one right here. Is 1 related to 4? No, that's false. And is 4 related to 1? No, that's false. There's nothing between them. And so now looking at our truth table definition, we can see that true implies true is true, 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 and false implies false is also true. So it'll be trues down the rest of that column. So this shows us that the statement in blue is true because for all possible combinations of two numbers, even if you pick the two of the same number, in A, we always get x is related to y, implies y is related to x. So this tells us that this relation defined in this graph is symmetric. But there's more that I want to say here. So the first thing is when checking the first thing I want to say is that when checking symmetry, checking for symmetry, notice what happened with all of these here. If there's no edge between something, then the P is going to be false. So then the overall statement is always going to be true. So if there's no edge between two things, you don't need to check it. You don't need to check for symmetry there. Okay, another thing that I want to say is that notice when you have this situation, that 1 is related to 2 implies 2 is related to 1. That means that if that's true, if this is true, right, true here, then we know immediately that this is going to be true. So it's redundant to check these cases. And lastly, self-loops. Self-loops will always pass the test for symmetry because true implies true. So we really don't need to worry about this case either. All we have to do when we're checking symmetry is check, okay, if there's an edge from one number to a different number, is there an edge back? Right, if there's an edge going over, is there an edge going back? If there's an edge going over, is there an edge going back? That's all you got to check.